Good morning, children. So now we are going to discuss a topic as torque acting on a body. You know that when an external force is acts on a body, so it has accelerated motion and hence there is a translational motion. Similarly, we can consider the situation which a body has a rotational motion when a force acts on this body at a certain distance from the axis of rotation. So we can consider this situation as the product of force acting on this particle and the distance from where this force is acting from the axis of rotation. So that is considered as a new physical quantity. So that we call it as a torque acting on this body. So that is known as a torque acting on an object. So we can say that torque acting on this object is considered as torque O is equal to what is that R cross F, we can say that. So it is a product of magnitude of the force acting on the body and what is that perpendicular distance from the axis of rotation at a point from where this force is the x. So here we can understand that situation in which help of an example. Suppose we are considering a situation in which a particle is in an xy plane. Like this, we are considering the case of an xy plane and a particle. I mentioned this point as a P, so which is lies in the xy plane, and we are considering a situation in which the force is act on this particle along this direction. Let F be the force is act on this particle, and we can consider that R is the position vector of this particle from this origin. And this is the, we can say that this is the line of action of this position vector, we can say that. And the force makes an angle theta with respect to this position vector R. So in this case, we can say that the torque acting on this particle is considered as, what is that, torque tau is equal to R cross F. That means, it is a product of magnitude of the force acting on this particle and perpendicular distance from the axis of rotation. So actually this is a rigid body only. This is rigid body. Rigid body is performing a rotational motion with respect to this axis. And in the rigid body we are considering only one particle for our understanding. Now we can consider a situation which we can see that suppose I am extending this line of action of this force. You can see that here in this manner, and if I am drawing a normal along this direction, you can see that suppose I am taking this as an angle theta. This angle is theta, so we can take this angle as theta. So we can see that opposite side is coming as what is that R sin theta, we can say. That means this R sin theta we call it as one more name. So this is known as R sin theta, we can call it as a lever arm. So we can say that torque in one more method, what is that? Torque is considered as the product of magnitude of the force and this lever arm, we can say R sin theta, we can say. So torque tau is equal to what is coming? R F sin theta. Or we can say torque tau in vector form as torque tau is equal to R cross F. So this is the way we can represent the torque acting on this particle. Okay.